Class 10, Chapter 2, Polynomials, Module 3 and 4. Objectives. In this module, you will learn about relationship between zeros and coefficients of a polynomial and division algorithm for polynomials. Dear students, last class we have studied how to find out or how to factorize the polynomial. After obtaining the zeros of the polynomial, we verify the relationship between the zeros and the coefficient of a polynomial. Some other type of questions from that exercise itself. Then second one is division algorithm for polynomials. Now listen carefully the question. So these are simple questions and also important one. First question. Find a quadratic polynomial, each with the given numbers as the sum and product of its zeros respectively. So listen carefully, the given numbers are sum and product of its zeros. So sum of zeros, how we represent it last class? We represent that is alpha plus beta. And product of zeros what? Alpha into beta. So alpha plus beta, sum of 0 is given as what? Minus 3. And product of 0 is given as what? 2. Now we know the standard form of the quadratic polynomial. What is that? Yes, ax square plus bx plus c. And its zeros, we can take it as alpha and beta. Now what is that first one? Alpha plus beta. So alpha plus beta is given what? Sum of 0 is what? Minus 3. So minus 3 can be written as what? Minus 3 by 1. So sum of 0 we know what? Alpha plus beta is equal to minus b by a. And product of 0 is given as 2. That is alpha into beta is 2. 2 can be written as 2 by 1. Equate that with what? Product of 0 c by a. Now compare all that. So what is the value of a there? A is equal to 1. Now minus b is equal to minus 3. Then what is b? Yes, b is equal to 3. Then next is c. When we compare it, c is equal to what? 2. So one quadratic polynomial which fits the given conditions. Which are they? a is equal to 1, b is equal to 3 and c is equal to 2. So the polynomial is what? X square, ax square. Instead of a what? 1x square. That is x square. Then what? Bx. So 3x plus c. C what? 2. So x square plus 3x plus 2 is the required quadratic polynomial. Clear? Now same type. The second one what? Sum of 0 is given as what? 1 by 4. And the product of 0 is given as what? Minus 1. Our standard form is what? Ax square plus bx plus c itself. And the zeros are alpha and beta. So first equate. What is sum of 0? Alpha plus beta is given as what? 1 by 4. Which is equal to what? Minus b by a. And product of 0 alpha into beta what? Minus 1. So minus 1 is what? Minus 1 by 1. So listen carefully students. The first one, alpha plus beta, the denominator is 1 by 4. Alpha into beta, denominator is what? Minus 1 by 1. Both the denominators are different. But when we compare it, alpha plus beta is minus b by a. Alpha into beta is c by a. Both one, the denominator is same. So here also we need to change the denominator into same. So to change minus 1 by 1 as the denominator as 4, we need to multiply both numerator and denominator by 4. So minus 1 by 1 into 4 by 4, which is equal to minus 4 by 4. Is equal to what? C by a. Here, when we compare all that coefficients, that is the standard form. What is a? A is equal to 4 minus b is equal to what? 1. So what is the value of b? b is equal to minus 1. And the value of c is equal to what? Minus 4. Now we need to write the quadratic polynomial. So the required quadratic polynomial is what? Ax square. Instead of a what? 4x square What is the value of b? Minus 1. So 4x square minus 1x, c value minus 4. So minus 4. That is ax square, 4x square minus 1x minus 4. Now the next one, sum of 0 is root 2. So listen carefully. This question is very important. Okay. So sum of 0, root 2, and product of 0, 1 by 3. Same way itself. Let the quadratic polynomial be ax square plus bx plus c. And the zeros are alpha and beta. So first, alpha plus beta is what given? Root 2. So root 2 is what? Root 2 by 1. Now the second one, alpha beta 1 by 3. There the denominator is 3. So we need to change the first root 2 by 1 as the denominator as 3. So we multiply both numerator and denominator by 3. That is into 3 by 3. That become what? Root 2 into 3, 3 root 2 by 3, which is equal to alpha plus beta what? Minus b by a. And alpha beta is equal to what? That is given 1 by 3, which is equal to c by a. Now compare it. What is the value of a? Is equal to 3. And minus b is equal to 3 root 2. So b is equal to minus 3 root 2. Now c is equal to what? 1. So the required quadratic polynomial is 3x square minus 3 root 2 plus 1. Okay, so this type question is very important. Now the next one, if it is the alpha plus beta, sum 0 and product alpha into beta root 5. Now starting the same way itself, let the quadratic polynomial be ax square plus bx plus c, and its zeros be alpha and beta. Now sum of 0 alpha plus beta what? 0 is given. 0 can be written as what? 0 by 1, which is equal to minus b by a, and alpha into beta root 5 by 1 is equal to what? C by a. Compare all that values. Then what is the value? Both the alpha plus beta and alpha beta is equal to 1. Now minus b is equal to 0, b is equal to 0. Alpha into beta is what? 0, root 5 by 1 is equal to c by a. So what is the value of a? 1, b is 0, c is equal to root 5. Now what is the required quadratic polynomial? Yes, 1x square, that is x square plus 0x plus root 5. Now listen carefully students. These questions are simple one and 1 mark, sometimes 2 mark also. Okay, so important type of questions. Then the next one objective is what? Division algorithm for polynomials. Have you heard the division algorithm students? Yes, in this year also the first chapter Euclid's division algorithm we know. What is the division algorithm? Yes, dividend is equal to divisor into quotient plus remainder. So here the divide and verify the division algorithm means we need to divide the first polynomial by the second polynomial. The first step is we need to check whether these polynomials are in the standard form or not. So in this case, this one is in the standard form. So we need to divide the dividend 2x square plus 3x plus 1 by the divisor x plus 2. So the division first step. So you need to change the first term of the divisor x in as 2x square. So to change x as 2x square, we need to multiply x into 2x. So when you multiply x into 2x become 2x square. Then multiply the second term 2 into 2x. So that becomes plus 4x. Now after each division we need to subtract it. So the easy way is what? Change the sign then add it. So 3x instead of 4 plus 4x become minus 4x. We change the sign. After that add 3 minus 4x. So 3 minus 4 is what? Minus x. Then plus 1. Now same way to change that x, the divisor x into minus 6. Multiply x into minus 1. So minus x Minus 1 into 2 become minus 2. Now we need to change what? We need to apply the after the division we need to subtract it. So for the easy way is what? Change the sign then add it. So when you change the sign plus signs, that is 1 plus 2 is equal to what? 3 become. Now listen, the divisor into quotient, that is what? 2x minus 1 is the quotient into x plus 2 is the divisor, plus the remainder 3 is equal to what? When you add all that, what we get? 2x square plus 3x plus 1. That is which one? That is the dividend. Now the division algorithm is what? Dividend 2x square plus 3x plus 1 is equal to divisor into quotient plus remainder. Okay. So the next one also the same itself. Here also we need to divide the first one by the second one. Here also the second one is what? Not in the standard form. So change it to standard form. That is the divisor 1 plus 2x plus x square as what? We need to change it into x square plus 2x plus 1. Now for the division, first the dividend is 3x cube plus x square minus plus 2x plus 5 divided by x square plus 2x plus 1. The first term is what? To change x square into 3x cube, we need to multiply it into 3x. Then multiply the second term also using 3x. So 3x into 2x becomes 6x square. Then 3x into 1 is equal to what? 3x. After each division we need to subtract it. For that, change the sign then add it. So x square minus 6x square become minus 5x square. Same as minus 2x minus 3x become what? Minus 2x. Then change the sign. Then that become what? Plus 2x minus 3x become minus 1x. Then plus 5. After that, x square to change into minus 5x square, we need to multiply by minus 5. So minus 5 into x square become minus 5x square. Then minus 5 into plus 2x become minus 10x. Then minus 5 into plus 1 become minus 1. After that, the same way when we perform the subtraction, change the sign. Minus x plus 10x become 9x. Plus 5 become 10. So the remainder is what? 9x plus 10. Now apply the division algorithm. Divisor into quotient plus the remainder. When you multiply all that polynomials, that is a multiplication of a binomial by a binomial, a binomial by a trinomial, etc., that we have studied in the lower class. Thus we verify the division algorithm. Dividend is equal to divisor into quotient plus remainder. Now if p of x and g of x are any two polynomials with a g of x not equal to 0, that means if p of x is the dividend and g of x is the divisor, then we can find the polynomial q of x quotient and r of x such that p of x, the dividend, is equal to g of x into q of x plus r of x, where r of x equal to 0 or degree of r of x less than degree of the g of x. This result is known as what? Division algorithm for polynomials. Now the same one more division. Okay, divide the given polynomial by the second polynomial and verify the division algorithm. So first you need to change all that polynomials into its standard form. After that we can perform the division. So to change minus x square into minus x cube, multiply with the x. After that, each term we need to multiply using x, then subtract it. So subtraction easy way is what? Change the sign then add it. Then the second term is what? Minus 2, the quotient second term minus 2. Multiply using minus 2 After that we need to what? Subtract. Then at last what we get, the remainder is equal to 3. Now we can apply dividend is equal to divisor into quotient plus remainder. Then that LHS is equal to what? Divisor into quotient plus remainder, which is equal to what? The dividend. In this way the division algorithm is verified. Clear, students? Okay, thank you.